Hey everybody, it is Merm here, and this is a little AP Bio video on statistics. So, statistics is one of those areas that we just really got to make sure we understand at the beginning of the year, because every time you look at data, you want to be able to say, like, all right, what range does this fall in? Is this acceptable? Do we think our experiment is valid? Do we think that our results fall within a normal range? So, let's get right into it. So first of all, some terms. So N, a capital N, is when you talk about sampling an entire population. So all. We almost never actually use the population because who's going to be able to really get everybody and all the data? So instead, we use a little n, which is our sample, and then we gather data from our sample, and then we can make predictions, and then we can use those predictions to guess what would happen to the overall population. But really, we're always working with a sample that we can manage. So N is our sample size. So you might have a sample, you might be doing a study and you work with 100 people. So your sample would be 100. It's not everybody, it's not the population, but hopefully you can use that information to make some predictions for the population. All right, some other terms. This X bar is equal to the mean, and you think of the mean as the average. So if you have a group of data, add them all up, divide by the number, the n, the sample size that you had, and you'll have your average. M is the median, capital M. And so the median is the midpoint. And if you have an odd number of data points, you just line them all up. So like, let's say I had 2, 2, 3, 5, 6, 8, 9. All right, so 1, 2, 3, 4, 5, 6, 7. So my N, my sample, is 7 here for this case. So 3 off the top, 3 off the bottom. My median or my midpoint is 5. And now if you have an even number, then you should just take the average of the two in the middle. Average of the two middle. All right, so let's keep going here. Hopefully all of the things I've said so far is really just a refresher. And your range is how far your data like how it extends. So ours went all the way from 2 to 9. So we have a range of 7. Okay, what else? Next thing. All right, degrees of freedom. This is probably a new term for you. Degrees of freedom. So if I had a formula like A plus B plus C equals 10, I have 3 variables or 3 unknowns right now. So I have the freedom right now to assign A to any number. So I could say that A is 4. All right. And then B, I also have the freedom. I can decide whatever I want. I could say B is 3. Now, C, I have no freedom because I know that this is 10. So 4 and 3 is 7. So this has to be 3. I have 0 freedom to decide what that value is. So these two I decided. So these I was free to decide. So I have 2 degrees of freedom. And I had 1 that was already selected for me based on the math of this problem. So degrees of freedom is always equal to N, your sample size. So right here we have 3 samples, minus 1. So N minus 1 is always my degrees of freedom. I got to pick two of these, so I had 2 degrees of freedom. You use degrees of freedom when you are calculating standard deviation and when you're calculating chi-square. So they will come up frequently. So let's get right into standard deviation. So standard deviation, I'll write it out first for you, is abbreviated with an S. And here is the formula. It's equal to the square root of the sum of x minus x bar squared over the degree of freedom. So it sort of looks like this intimidating, huge formula, but I'm going to do an example with you so I can show you that it's really not so much. And actually, let me just explain a little bit more about standard deviation anyways. So this is the normal distribution of data. And you think of the normal distribution of data as a bell curve, like this. Actually, let me start a new screen so I have a little bit more room here. Okay, so within my bell curve, the middle point is my average. That's my mean. And so a standard deviation is a measurement that shows me who will fall within that range. So within one standard deviation under and one standard deviation over, this will be 68% of my data. 68% of my values is going to fall in this area here. Now, if I keep extending it, if I go out 2 standard deviations this way and 2 standard deviations this way, I will have 95% of the data fall within that range. And if I go to 3 standard deviations, both directions, I will now have 99% of my data. And that's how a normal bell curve works. Now, not every curve is super steep. Sometimes you have a curve that's like this. And what it tells you is that this has a really small standard deviation, and this has a larger standard deviation because the data is more spread out. Here the points are closer, here it is more spread. So that's why I can tell it's a larger difference. Now let's just talk about it for a minute in terms of things. Let's say I'm looking at leaves. So here's my plant. If I can have leaves that have all these different sizes, when I figure out the average, so let's say the average is right here, the standard deviation is how different do they really get? So this has a pretty large standard deviation. But let's say I'm looking at something else. Like let's say I'm looking at how many, okay, you know how you have a leaf like this? Sorry, I'm such a bad drawer. Let's say you're looking at the number of veins. And when you look at these plants, you go, all right, 1, 2, 3, 4, and 1 main, 1, 5. And you do your data, and pretty much everybody falls right here in the 5. That's when you get a really small standard deviation because everyone got 5. Everyone was really, really close. So I think in the last video that I made earlier today on Zoom, I said if you were thinking about something with a really low standard deviation, everybody is very similar to each other, and something where you have really high standard deviation or great standard deviation is something like, I think I used trees in a forest, so, or trees in a park. And you could say, hey, if you went down to Pineway Ponds, there's only 5 trees per acre because there's so many areas that are cleared to be a soccer field or a football field or whatever. But if you went to Letchworth, there might be 6,000 trees in an area. So there's a huge range, and that huge range is going to lead us to have a very large standard deviation. So let's get to work and do the math. So I'm going to give you some data. So I am going to call my data X. I'm going to have to figure out X bar. I'm going to have to figure out the average. Then I'm going to do X minus X bar, and then I square it. Because my goal is to be able to add up this column here. So I have these different data points, 10, 12, 16, 9, 18, 22, 17, and 12. So 1, 2, 3, 4, 5, 6, 7, 8. My N is 8, and my degrees of freedom is 7. Okay, so first thing I'm going to do is add these up, and I get 116. 116 divided by 8 will give me the average. So the average is 14.5. I just write it like that because I'm not going to rewrite it all those times in there, but I know for every column the average is 14.5. So what you do is to figure out this difference, you go 14.5 minus 10, so that would be 4.5. And then 4.5 times 4.5 is 20.25. And then I do the same thing again. The difference from 12 is 2.5. 2.5 times 2.5 is 6.25. And I'm going to keep going. Okay, and once I've done all that math, my next goal is to add all of these up. Don't know why this is moving on me. Stay still. Okay, so I add all these up and I get 140. So this number is what goes on top. That's the sum of x minus x bar squared. So this is 140. Over, so S was equal to this, n minus 1. So I had 8 in my sample size. 8 minus 1 is 7. All right, 140 divided by 7 is 20. So S is going to be equal to the square root of 20. I go punch it in the calculator, and I get 4.47. And usually anything on AP Bio, they're going to tell you what to round to. They usually tell you to round to the 100th place. So that is how you do all the work out to calculate standard deviation. So what that tells me, if I make a little graph, so my average here is 14.5. And then if I go this way, what was it, 4.47? So let's just say 4.5. I'm just making it easier for this right now. That would be going up to 19. And if I go this way to 4.5, that would be going down to 10. So for my curve, this is 68% of my data is falling in this range between 10 and 19. Okay, and then if I kept going, if I went out another 4.5 and another 4.5, that would now include 95% of my data. And I could keep going one more and one more, and now I would be all the way including 99% of the data should fall within that range. That's how a standard deviation works. And while I'm at it, might as well show you one more thing. When you have data, it could be plotted like this. And this is the average. This is the X bar. And it'll have little lines like this and like this. This, it could be standard error, but it also could be standard deviation. So if they tell you these are standard deviation bars, it's plus or minus that 4.5 here. They can do the same thing with a point graph like this. And so this is my X bar plus or minus 4.5. And so that's showing my average point plus or minus my standard deviation. All right. Thanks for joining me. Make sure you ask away, ask questions if there's something you don't understand. And I also posted lots and lots of practice for you to do.